Okay, let's get into it. Today we're doing a deep dive on a really critical piece of hardware, the Thor Broadcast F-EDFA-22.
That's right.
Our mission here is to sort of strip away all the technical jargon and really figure out what this thing does and why it's so important for high-speed data.
It's a fun one because what we're really looking at is the ultimate workhorse of modern fiber optics. It's a general-purpose optical amplifier.
General purpose, but it's for a very specific job.
Exactly. It's engineered for this tiny slice of the light spectrum from 1540 to 1565 nanometers.
And that's the DWDM band.
That's the DWDM highway. Think of it like stacking dozens of lanes of traffic onto one single road. This amplifier is what keeps the cars in every lane moving at top speed.
Okay, so if it's a booster, let's talk about that raw power. The spec that really jumps out is the output.
It's rock solid. That's the key takeaway here.
So how consistent is it? I mean, what's the worst signal it can take and still perform?
Well, that's the amazing part. It gives you a really strong, consistent 22 dBm output. But more importantly, it doesn't matter what you feed it.
What do you mean?
The input can be this dying whisper at, say, -10 dBm, or a really strong signal at +10 dBm.
And the output is the same.
The output is that clean, powerful 22 dBm. Every single time, it's like a perfect power regenerator.
That's incredibly reliable. But if it's working on that main fiber highway, does it care what kind of traffic is running on it?
Not at all.
So broadcast signals versus, like, pure internet data.
It absolutely does not care. It's what we call protocol agnostic. It just sees light in the 1550 band and amplifies it.
So anything goes.
Anything. High-speed digital, high-speed analog, optical RF signals. It handles it all. And that versatility is, it's just huge for system designers.
Okay, so the power is incredible. But what about the speed? Boosting a signal usually means reading it, regenerating it, and retransmitting it. That adds delay.
It does. And that's where the EDFA technology, the Erbium-Doped Fiber Amplifier, is just brilliant.
How does it work?
It amplifies the light signal itself, optically, using this special erbium-doped fiber. It never converts it to an electrical signal.
So it completely skips the signal processing step.
Exactly. And the huge benefit there, you get virtually zero latency.
Zero latency, that's the game changer.
It means instantaneous signal distribution. It's essential for, very long-distance fiber transport where every millisecond counts.
Or for something more complex.
Yeah, or for feeding a fiber optic PLC splitter, which is, simply put, just a high-speed fiber hub you'd find in a broadcast center, something that sends one signal to many places at once.
And the components have to be top-notch for that.
Oh, absolutely. It's using a high-quality pump laser and OFS erbium-doped fiber that's actually made right here in America.
So for the operators who have to keep these things running 24/7, what about management? How do they keep an eye on it?
Reliability is paramount. Physically, it's just a standard 1RU rack unit, but that operational temperature range, from -5 to 65 degrees Celsius,
That tells you something.
it tells you it's built to survive in a hot server room or a cold remote outpost. For remote management, you have a basic SNMP system over an RJ45 port for monitoring and an RS-232 interface for deeper control.
Okay, here's a real-world question.
Yeah.
What happens if a fiber line gets cut? A sudden power change like that could fry the internal laser, right?
It could, and that's where some really smart integrated safety design comes in.
How does that work?
There's a signal detect warning alarm right on the front. If the input is lost, if someone unplugs a cable, that alarm automatically and instantly switches off the pump laser.
So it protects itself.
It protects the hardware from burnout. That feature alone can save you thousands of dollars when something goes wrong in the field.
So let's sum it all up. The key takeaway here is that this amplifier is built for the absolute toughest jobs. You get high reliability, that consistent 22 WM output, and crucially zero latency for basically any protocol you can throw at it.
Right. And that brings up a really interesting thought, especially when you look at today's price of $2,795. It kind of leaves you with a question.
Which is,
Considering that price and that level of perfect performance, what complex, high-stakes application out there, maybe it's high-frequency trading, maybe it's live global broadcasting, what problem demands that level of flawless zero-latency amplification? That's the kind of challenge that justifies this kind of investment.